start recording here and sharing my screen. This class is the third method for deterioration. And in this method, what you have is two condition assessments, whether this is International Roughness Index like shown in this map on screen for 2 points on time. In this case, we have the year 2015. We have those points over there, or the year 2017. Okay, so in this case, there's a separation of 2 years with the data we're dealing with. And for each of them, we have 35,000 roughly points. So you have here all your segments and the values of roughness for a specific year. This is the result of data collection. You have the same for the other year. Okay, so you have 2017. So we are trying to create a performance curve out of this. On a typical performance curve, when you have 2 points on time, it's not possible. You cannot do it. But there is one method that we can utilize. The method is going to define a calculator. And the calculator can be used for any indicator. So in this case, is PCI, but can be RI. Okay, so you just replace it. Or can be ratting, or can be cracking. Okay, so you're going to create groups. And for every group, you're going to have the first time or the first year and the second year. Or in this example I showed you before, it will be the 2015 and then the 2017. And then this is going to have, in the example I was showing you before, is going to have the roughness. And then you will have the roughness you observe on average on 2015 for a specific group, and the roughness you observe in 2017 for the same group. So I think it's easier if I show you an example here. So consider this information we have here. Consider we have these observations, 2009, 2010. As you can see, we have a group here of segments in roughness. We have another group here. And we have a third group here. I will appreciate if everybody close your microphone, please, unless you have a question. Now you see this group over here is low, so you can judge this as good condition from a roughness perspective. Now this group over here, maybe it's not that good. This will be poor. And finally, this group over here is somewhere in between, so it's going to be fair. Okay, so I'm going to get an average for my fair. So I'm going to have my time, 2009, 2010. I'm going to have my fair. Actually, I'm going to sort them. So I'm going to have my good, my fair, and my poor. So for good, I'm going to have the average. This is 2009, right? So on average is 0.8871. And I can do the same for the other average. The average will be for 2010, okay? For the fair, I can get the average. And I can get the average for the following year. And for the poor, I can get the average. and I can get the average for the following year. Now, all these are the same homogeneous group. That means they belong to the same type of pavement structure, similar traffic intensity, similar environmental region. Okay. Now, notice this. I have movement from one point on time to the next one. So if I want, I can kind of plot this and have an apparent age, which I don't know what is the age because I don't know when was the last treatment that they did to this. And I have my condition. So I will have my condition for good. So this is gonna be good, 2009. This is gonna be good, 2010. And I can have the same for fair. So I will have fair 2009, fair 2010, and I will have poor 2009, poor 2010. So my fair 2009, my fair 2010, and my poor 2009, and my poor 2010. Now, I don't know what is this age, but I'm gonna just assume this is maybe 1 and 2 year old. And I'm gonna assume maybe this is something like 7 and 8 years. And I'm gonna assume this is maybe something like 14 and 15 years on the segments, okay? Just for now. We're gonna play with these values, we're gonna change them. But I'm gonna go ahead and I'm gonna plot this so you understand what is the approach that we're doing. And then we go back to the theory. So if you see, these 2 points over here, 0.88 and 0.99, they are the good group. These 2 points over here, they are the fair group. And these 2 points over here, they are the poor group. So I can actually go ahead and put a trend line, except that there's a little problem. This information, I just made it up. So I don't know if this is the real information. Perhaps this is 8 and 9. Perhaps this is 20 and 21. Perhaps this is 19 and 20. Perhaps this is 8.5 and 9.5. Perhaps this is 1.12 and this is 2.12. Perhaps this is 18.7456 and this is 19.7456. I don't know. What I do know is that this difference has to be 1 year. And this difference has to be, anybody? 1 year as well. And this difference over here has to be 1 year because they are separated 1 year. They go from 2009 to 2010. Okay, so the idea is that the good condition will be in a relatively low area with apparent age that is very recent, very young, the segment. And as I move through my groups, this is the apparent age. And as I move in my groups, the condition so as I move, the condition will get worse and worse because this group over here is my good condition. This one over here is fair. And this one over here is poor. If you have more groups, you can define more groups. Now, how did I assign the first one to be good? Well, because I look at it and it looks like 0.9 RI, 0.8 something RI is a good condition. So maybe I can define my good condition to be somewhere between 0.5 to 2. And maybe I define my fair condition to go from 2 to 4, maybe. And maybe my poor conditions goes to 4 to whatever, and up. Is this overall idea understandable? Okay. So this is the iteration curve, but I need this information. This is what I need to estimate. The way to estimate this is because I know this difference is 1 year. So I have to go and read what is this corresponding age here. What is this corresponding age here? And this difference that I observe here has to be exactly 1 year in this case. And the same is true for this second pair of points. And the same for this pair of points and for each and every pair of points that I want to establish there. So the way I approach this is by having my average RI for 2015. I call it AP11. My average RI for the following year, I call it AP21, is the second year. And then I need to have an associated age that is estimated for this RI. And I have to have an associated apparent age. So this is estimated apparent age. And the age difference has to match what I am observing. So let us take this and process this in a more formal way. This is the calculator to generate this type of performance curve. So now we're doing 2009 and 2010 values, right? And we have this value: good, fair, poor. So I have this pair of values. And I don't have values for very poor. This is the age, and this is the RI. So I say the good group is going to be here. The fair group is going to be here. The poor group is going to be here. The good goes from 0.5 minimum RI to 2. Now, the 0.5 is the absolute minimum I observe. That means that the apparent age that I have for that is 0. So it is brand new. For the good, the n is at 2. This is an arbitrary value, but it is the one I use to segregate and create this average that I observe here. So I have to respect it. And I don't know what is this value. All I know is that this difference over here, which is coming from whatever is the associated apparent age, estimated for this value, for the average, this difference, which is 0.39 right now, this difference has to be equals to 1. These values, the associated apparent ages, are coming from an equation. So we can have a quick look into it. If the value, if the value of condition is less than this maximum, which is the case, then I do the difference between the value of condition, initial, A2, 0.5, minus the observed value. So this is how far the observed value is from the beginning. And I divide that by this portion over here. You can ignore the rest of the equation. This portion over here is the difference between the minimum and the maximum divided over the difference between the ages. And this is the calibration value that I need to estimate, such that I force this as a 1-year jump. So as you can see, if I put this in 10, 11, 13, 14. Okay, so 14 will give me this value of 1 in the separation. The next value, I need to estimate this one so that the difference between these two goes to 1. 20, 22, 23, 24, maybe too much, 23. Okay, and the difference is almost getting there. Of course, I can put decimals here, right? So I can put 1399.
Professor?
Yes.
Sorry. So this column B, what is this age? Like
Apparent
where is
age.
this coming from? No, but
You,
the apparent age we
you
have like in column
establish
B,
a
right?
range. You establish a range for what you call good condition.
Yeah.
0.5 to 2. Based on that range, you went and you observed this average for 2009 and for 2010.
Yeah.
You know 0.5 is brand new, so age is 0.
Okay.
What you don't know is what is the corresponding age for the top of your range, which is 2.
Okay.
So you need to find out what is this value. To find out what is this value, the difference between the generated apparent age for the condition, the average condition you observe here, you notice these two are the same as these two, right?
Yeah, exactly.
This difference, this is calculated. This is calculated based on this equation. So that difference has to be 1. Why? Because you know it's from 2009 to 2010.
2009 to 2010. Yeah, okay.
This difference here in condition generates an apparent age, and that difference has to be 1 as well. And for each and every, it has to be 1. If I go for a different case like this, the difference will be 2 because it's 2015 to 17, right? But for the specific example I give you before, it has to be 1. And I'm still missing this one, so maybe that's too much. Okay. There you go. So now you have your graph. In your graph, you have now your pairs. And these pairs will give you a good fit. So before, I didn't know what was the age of these things. Now I do. So before, if you remember in the example I was doing here, I kind of put any values here because I didn't know. Now I can put the right values, which I just calculated with that calculator. So what are those values? 0.88 is 3.58. 0.99 is 4.59. 251 is 16.24. 272.5 is 17.23. 428, yes, 428, which is this value, is 23.81. And 468, which is this value, is 24.81. Now you can see this is 1, this is almost 1, this is almost 1, it's just 1 decimal. And now this deterioration curve I have obtained is truly giving a separation of 1 year for each pair.
Is it in a way we are kind of like interpolating between for a particular range, but to a certain target?
You are doing a linear interpolation between the two of them, and you are going for a linear for a 1 year target.
A 1 year target. Okay.
Now your trend line, you can go and adjust it, and maybe the exponential is the best fit for this. You can display the equation and you can display the R square. Now let us think about this. You have a split at 2. You have a split at 4, oops. So this is your good. This is your fair. And this is poor. Condition, right? And we're talking about RI condition. But let's think beyond this. What is the most common case when you have a country that don't have any pavement management system? Nothing. What is the first thing they do? You are hired by the government of the Christmas tree country. And they don't have a pavement management system. And they ask you, what should I do? Your answer probably will be along the lines of, you need to identify what is the current condition of your infrastructure. And after that, you need to measure how fast it is deteriorating. And you need to measure how effective are the treatments. And when is the best time to apply them. And how much they cost. And how much budget you have. And if that amount of money, what is the best way to use that money? What is the best timing? But it turned out that to get a good performance curve, you need years. And governments will go for 4 years, sometimes 5. And they want to show results as soon as possible. So this kind of approach can take 1 year. Why? Because you go and you do now in 2020 your data collection. And next year, in the same time, September, let's say, you go and you collect that again, and right away you can establish everything. You can establish a pavement management system with 1 year of time, because you can employ this trick to get your performance curve. Okay, now, I did not show you how to break this in homogeneous groups and how to obtain this from real data. So I actually have a real data set here, but I want to know if the idea in general is understandable so far, or you need further explanations on this. There is equations. This is an upcoming book that I'm publishing, and the explanation is here. So basically, as I said, you have your pair of years, you have your average values, you have the associated age, okay? And then this one is typically set because it's either 100 if it is PCI or is 0. No, pardon, this is 0 age always. That one can be established as 0 always. And this is if it is PCI is 100. If it is RI is probably 0.5. If it is cracking is 0. If it is ratting is 0, right? And this is the value you use for your first group. The value you use for saying this is the difference between good and fair. So if we have RI, this is your 2, this is your 4. And these are the values that you don't know what they are and you need to establish. But all these other values you know, because these are your groups. These are your groups. These are your groups. And then, as Cameron stated correctly, is a linear interpolation. Here. So this is the interpolation we're doing, right? We are taking a linear interpolation factor multiplied by the value of the difference between the value you observe and the previous breaking point, as we did. So let's look at a more formal data set. By the way, this is here, right? The data I'm using is there. So let us look at this. I have, before the class, put together the condition on 2015 and the condition in 2017. So this is 15, this is 17. However, notice you have a 0 here. That means the count of segments used to give condition here was 0. So there was no data collected that year for this segment. So we need to discard this segment. And the same might have happened here in the 2017. So we need to do a little bit of a cleanup. And also, please notice we know this is pavements. This is surface treatment. This is asphalt cement or hot mix asphalt. And this is traffic intensity. Okay? And you have the values here, as a matter of fact. So this is number of lanes. This is your AADT. And this is the segment, the length of the segment, and in what route it is. So I'm going to take this and I'm going to open this in Excel. Let me just save this one. We're not going to use this anymore. So we're going to open this file in Excel. I'm going to keep this one open. Okay, so that is the file. I'm just going to save it somewhere else because it's coming from the shape. And now see what you do. You have here 2015, 2017. Now, this count is important because whatever the count is 0, I have to eliminate that segment. So I'm going to filter this. I'm just going to put filters everywhere, actually. So wherever the count is 0, I cannot use this. Even though I might have a value here, I cannot use it because there's no data in this year. So I actually have to go and use whatever is not 0. And I also have to restrict this to whatever is not 0. Because if it is 0, there's no data in this year, although in 15 there might be data. So this is the one that will survive. I'm doing this today, guys, because you might need to do it for your final project. So I have 1,295 observations for this. Now, I have surface treatment and asphalt cement. I need to separate that. I cannot have it together. And then I have traffic intensity, okay? So I'm gonna create homogeneous groups now. I hope you hear that clear. So surface treatment first, or let's go for asphalt cement first. So asphalt cement and high traffic intensity. This is asphalt cement and high traffic intensity. This, I'm gonna get rid of that. Okay, so let's go back here. And now let's take low traffic intensity. Asphalt cement and low traffic intensity. I don't have environmental information for this, so it's gonna have to be combined together, unfortunately. And now this is medium. I know it's in Spanish, guys, I'm translating. And then I go back to my high traffic intensity. But it's gonna be for surface treatment. So TS is surface treatment. Surface treatment is a much thinner layer of asphalt cement. I only have for low and medium traffic intensity, which makes sense because high traffic intensity will not use a surface treatment. So let's go for low first.
Is it like microsurfacing?
Kind of something like that, yes. Yeah. It's chip seal. This is low, right? Yeah.
Excuse me, we should consider it as a flexible pavement or a rigid. Of course, it's not rigid, but can we consider it as a flexible?
The surface treatment is flexible.
Thank you.
And now we do the group for medium, okay? I hope, oh, there's only one. Okay, I'm not even gonna consider that group. All right. So let's go to my high. Let's do high first, medium, low. So I go to high. Now.
Excuse me.
Yes.
For composite pavements, we should consider a separate group or not?
Yes, of course.
Thank you.
Now, I need to extract those that are deteriorating. How do I know if a pavement is deteriorating?
If the average is going down, if the average is going high, so it's deterioration.
So 17 minus 15 is positive or negative?
If it's positive, so we have deterioration.
So if this is positive, we say 1, otherwise we say 0. So this is deterioration. This is deterioration. This is deterioration. This is not. So now I'm going to filter this. And this is my segments that are deteriorating. Very few, huh? As a matter of fact, I made a little mistake. I should have separated deterioration from improvement before, at the very beginning, to avoid having to do it for each of them. When I clean the data, I should have put the criteria and filter based on that, right? Now, let's sort. In 2015, from smaller to largest. So 155, 2, 3, 4, 6, 7, 8. Need to do the same here. So if you allow me, I'm just going to put the condition here for deterioration to avoid having to do it for all of them. Okay. So this is my deterioration. So this is what I should have done since the beginning, okay, guys? And then based on this, I should have taken my groups. Now, I already create the groups, so it's a bit too late. So I'm simply gonna go and apply the same criteria for all of them. Okay, so this is the iteration of the surface treatment and law. So this is asphalt cement law deterioration. And I'm missing this one, right? All right. So we're gonna sort. Why am I sorting? Anybody has an idea?
Make the homogeneous group to get that range for the IRI?
Yes.
Or to make apparent age?
Yes, exactly. So let's look at the distribution of what I have. So, you know, you can't even change the number of bins and so on and so forth, but apparently the minimum goes from 136 up to 12. Okay. So before we had a stringent range because we were talking about Canada, for instance, but this is Costa Rica, so they are more relaxed in their values. So I need to establish now a range for what is good, what is fair, what is poor, what is very poor. Look, I don't start in 0.5, I start in 136 as my minimum. Okay? If I go to 2017 and I try to observe my range from 147, so it's even worse, to 13. Okay? So what am I gonna call my good, fair, poor, very poor? I know my absolute minimum is 136. I know this goes up to 13. We just saw it, right? $13.5 actually. So I'm gonna propose up to 3. Up to 6. To 9. And on. Somebody wants me to adjust that?
Excuse me? Can we use the percentile command in Excel for find the good, fair, or poor, or very poor?
The percentile?
Yes, the percentile, as we can use for 0.25 for example, for good, and after that from 0.25 to 0.50.
But the percentile might tell you something. You see, this is skewed to the left. So your percentile at 25% is gonna be where? In 2 point something? Do you see how this is skewed to the left?
Yes, yes, yes.
So your first percentile is gonna be skewed to the left. Your 50 percentile is gonna be skewed to the left. And then you're gonna have a big tail on the other 50%. And also you need to match it with values that you know roughly follow local practices. Local practices meaning you go and you assess with a machine, you go with a laser profilometer, and you measure what is the roughness of a road that has been scheduled for mill and overlay, or one that has been scheduled for microsurfacing, or one that has been scheduled for reconstruction. So maybe the reconstruction is here. And maybe the mill and overlay is here. But you have to go and measure this on site. So it is a little more difficult. Now, the good thing about the method is that we will be breaking the data in and using all the data. So having a wrongful breakpoint here is not that big of a drop. Actually, we will be playing with these thresholds a little bit. You will see soon. So we have 2015 and you have 2017, right? And this one is gonna be for a specific homogeneous group. My first one, which is asphalt cement high ADT. And you need to notice that this is for the deterioration only, because it's a deterioration curve, right? I cannot put in this improvement. So what are these average? What is the average 15? What is the average 17? Okay, so I say good is this value, right? So let's go and let's see. So good is up to 3. So this is my good, up to 3. So this is the ones I use for that first average. And now you see, we just arrived at the point we were in the previous example, but you see all the work that it takes to prepare the information before that. What is my fair? Well, what did I define? Because once I define, I have to stick to this. 30126. Is this one. And what is my poor? Is 6 to 9. In this case, I have an average out of 2 observations. This is not good. I will prefer to have more. So we might have some unstable results at the end. But this is my group now. Let's go for the next one. I have my 2015, my 2017. I have my good, fair, poor. Maybe I do have very poor here. So up to 3. Actually, I say 3.1, right? 3.01. So, okay. Let's change it like that. What am I here? So this is up to 3. So is this. This is my good. Here, notice the last value goes beyond 3, but it is starting before. You see that? Because it is based on the initial year. How you respect the ranges is based on the 2015, not on the 2017, and you use the same values. The fair will go 3 to 6, right?
Sorry, Professor, what did you do in this case? Because we have sort of like different range for both years. Can you please go back?
Oh, same range.
No, but we
18 to 18, 19 to 41.
Okay, all right.
What I'm saying, Cameron, is this. It is up to 3, right?
Exactly,
so this
yeah.
is up to 3,
yeah.
but
yeah.
when you look at the other one, this is beyond 3.
This is beyond 3, yeah.
But
we still use the average of
no,
same?
you base that in this.
Okay.
And you use the entire same range for this average here.
For this average, okay.
So you ignore if this runs over the interval. It is
see.
based on the initial year. Always.
Okay, that's what I was asking. Okay,
yeah.
Thank you.
So this is 6 to 9. And I don't have range for very poor, okay? Is it clear the idea, or should I do it for all of them? I think I'm gonna do only these 2. Now.
Can I ask a question, Professor?
Yes.
And this method is always based on the initial year?
Yes.
Okay, thank you.
So I'm gonna take this one and bring it to the calculator now. Now, please notice, this is 136, this is 3, This is 6. This is 9. Three, 6, 9. Yeah. I lost where I process the data. Oh, here. So this is asphalt cement medium deterioration, okay? Okay, do I have the high traffic somewhere in here?
Yeah, you did it.
Yeah, here, right?
Yes.
The delta H is 2 now. Why?
Because 2015 to 2017.
Yeah, okay. 2015, 2017. Copy the values. Paste the values. Now this is 0 and 0. We don't have very poor. The ranges are incorrect. 136, 3, 6, 9, 12.
How are you setting these edges?
Experience can run, but
Okay.
you have to check.
Okay, all right.
I created this method actually.
Yeah, no, I understand that. So,
okay. But look.
Can we use the the standard World Bank? Okay.
Look what you have. Look what you have.
Yeah.
Right now is 119, and it is set from last time you used it. Is set at 5.398 years.
Yes.
These are years.
Yes. It's the current age.
But it's giving you a separation of 119. You need more separation. So what do?
Yes.
You have to stretch it apart. How do you stretch it apart? You know it has to be bigger than 5. How far bigger?
Yeah.
Put a 9, almost there. Put a 10, you went beyond.
Okay, so we can start with any number sort of based on like close to what we expect those.
Yeah, but there has to be a sequence, right? Because these
exactly.
3, 6, 9, we're clear where it's coming from, right?
Yes, exactly.
Is the range I established arbitrarily to be able to come here and get the average from this, right?
Yes, yeah.
And then from this. That is the first column, this one. The 1, 3, 6, 9, okay?
That's our range.
This has to be a 0 because it's brand new.
Yes.
It's always 0. Now, this one I don't know. I need to figure it out. But I look at this value here. Okay, I look at this value here. Yeah. And then I know I need to change this until I accomplish a 2.
Yeah.
So that change depends on how many years?
In how many years of what?
I mean, you said 2 years now, 2015 to 2017.
Yes, that's why it's 2. Before it was a separation of 1 year. Now it's a separation of 2 years.
2018, so it's going to be 3. So we're going to fix that until it's going to be
If
3.
you had 2015, 2018, then the separation will be 3. Yes. Correct.
Thank you.
But the most common case is 1 or 2 years. Because you will see most of the times when a government tries to use this method is because they want within the same government to be able to deliver results. Otherwise, people don't vote for them. They don't want to go and tell people we have to wait 10 years collecting data until we can establish a pavement management system.
Okay.
So this is typically 1 or 2 years maximum. Now I'm into here. Now I need to change this one. Okay. Now this is negative because this 15 is less than that. As soon as I make it bigger, it will get there. Okay, 30 is there. And now, of course, if I look at the curve, and if my Excel responds back, you see the pairs of data here, separated by 2 years exactly. Why? Because this is 546 and this is 746 or 747, so it's 2 years separation, okay? 1327, 1527, so it's 2 years separation. 2410, 2610. You can still adjust this a little bit if you want to bring it down to exactly 2. Almost there.
Excuse me.
Yes.
How Excel understand to draw line between each 2 points?
No, this will be a best fit. So you will come here and you will go for your best fit.
What about each 2, the lines between 2 points, each 2 points?
You establish that in the format.
Dashed, yeah.
You establish that in the format for Excel. So each of these is a separate pair. Is this pair, and then that
okay.
pair, and then the other pair. They're separated.
Okay, okay, thank you.
But this line between the 2 of them is not really important. What is important is the best fit you can get out of.
Yes, I know.
Right?
Exactly.
In this case, maybe the linear is a good, yeah, maybe the linear is the best now. Or maybe a polynomial. Apparently, polynomial is the best. But that's not the main point I want to make. So we're going to go to the next group. I'm going to do 2 groups, okay? And I'm going to use my other group, which is this. I don't have nothing here. I need to adjust it because the quality is much worse.
So, Professor, in the beginning, you said that just ignore rest of the equation and just focus on the first part. But I'm assuming the rest of the equation is basically for the other intervals, right?
No.
No? Okay.
Is this. Look at this, Cameron. This is the beginning, okay? I established this. Now I need to go and establish these ones.
No, I'm talking about the formula under
yes, I know
B.
what you're talking about.
Okay, okay.
Look at this value. 642 goes beyond this value here.
Yeah, yeah.
So sometimes this value runs over this. So this next range will impact this range here sometimes.
Okay.
Let's see.
Okay.
Put a 9 there. Put an 8.8 if you wish there. 8.7 maybe. Now you try to come here and you think this will not change, the 206, right? Because you could be playing with this value.
Yes.
But it does.
It does.
You saw it?
Yeah.
Because it's impacted by this one.
Okay.
Because sometimes some of these are moving from one range to the other one. See this age?
Yeah.
And see this value. This 303 is beyond this point.
Yes.
So it's giving me troubles. And sometimes if this goes beyond this point, it's gonna give me troubles.
Okay.
So there's no point for me to go very, very, very refined at the beginning.
Yeah.
You saw how I just stopped here and I was good enough because I know this one might change it. So first I go and do a rough adjustment to get close, and then I do a fine tuning.
Closer, and then the fine tuning. Okay.
Okay. Now, the next thing that is interesting is comparing this curve here with this curve here. Sometimes, even though it's a separate homogeneous group, now this is my high traffic intensity asphalt cement, and this will be my medium traffic intensity. I don't have environmental group. But sometimes, when you put them together, when you plot them, they look very similar. So we can do that. We can go and plot. So this is AH3, AH2. AH3, AH2. So these squares here are these squares here. No, the circles, sorry. The circles there are coming from here. And if you put together, you see it's not that far the information you observe. Sometimes that might happen. Now, of course, we want to go back here and continue with the same procedure for every group. So what is my next group? This one. Now, you guys, you're gonna guide me. What should I do?
You have to create your intervals for the condition quality.
I have to establish my average for this, right? Good, fair, poor, 15, 17. Based on the intervals as Nojan is suggesting. Good, fair, poor, maybe very poor, I don't know. Okay, so what is my first interval? We all agree it is 1.3 to 3, right? And this is 3 to 6. And this is 6 to 9. And this is 9 to 12. Up to there. Ah, this is not sorted, guys. You see how it's not sorted? So I cannot do it yet.
Hi, Professor, can I ask a question?
Sorry,
The average range is calculated from the all data that we have now, yes? The average range for example, from 1.3 to...
Because if I calculate that only from this one,
Yeah.
there was some of these that had very few, so I don't have the complete picture. It has to be before I break them down in homogeneous groups.
Before breakdown to homogeneous group, yes, yes. Thank you.
Yeah. So this is not sorted, okay? Now it is sorted. So now I can go and I can say 2015, 2017, good, fair, poor. I have more data here. I'm gonna have a much better average. There. So up to 74, okay? Now, the next one is 3 to 6. Oops, sorry. So it is up to 264. 75 to 264. 75 to 264. 75 to 264. Okay, just in case you didn't believe me. $75 to 264. And the poor is 9 and on, right? Starts here. So it is 326. Hold on a minute. What is this? 264. And the other one is 265. Ah, no, pardon. 6 to 9 is the next one. So is this. So it's 265 to 325. 265 to 325. Okay, so I can go in the same way. I think in this one I have very poor, right?
Another group, yeah.
$326, I don't know what is the last one. I don't think I have 400. So now I can go with this into my calculator. And I have my new values. Now, again, this is incorrect. And this is incorrect. I need 2. So let's see. Okay, roughly there. Roughly there. Roughly there. Roughly there. I fine-tune it now.
Is the change, should be changed to 2 years?
No, it's just for me to remember, but what it matters is this visualization. Yes, you have to change it here, and you have to change it here, but that's only for a visual aid for you. What matters is this one. This is the one that is being calculated from these two.
Sorry.
Yeah, no problem. But you see how the second one is changing as I change this, right?
You can use goal seek.
Yes, I can use goal sig, but sometimes the goal sig might get confused.
Yeah.
Because it's multiple values that are affected. So let's see, this one is, I'm almost there actually. I can leave it there. And this one, I can probably bring it here. And this one, I can probably bring it a little less. There, that's good enough. Okay. So now you have performance curves for this. And this is the method I wanted to present to you guys today. I'm gonna let you practice with the method. I'm gonna stop the recording for now. I'm gonna pause. Okay, so all we have done at this point new is just open a data set for PCI, and I'm recording now, that's why I'm repeating, and establish the percentiles. The 33% for ESALs and the 66% for ESALs, and separated the information in rigid and flexible pavements. This is for flexible pavements. So these two values, I'm gonna actually copy somewhere else. ESAL percentile. I'm just gonna put it here for now. Because I am going to sort this data. ESALs. Smaller to largest. And I need to go up to 5,386,000. 5,386. Okay, up to here. And this will be my low ESAL intensity. Flexible, low ESALs. Okay. Now for this one, we will have to go PCI 2009, PCI 2010. I don't like the fact that the columns are inverted, so I'm just gonna switch them. We're gonna work with these two columns. Evidently, we have to go back here and now separate the next percentile, which is from 583 to that. I'm not gonna do it. I'm gonna go ahead with the rest of the procedure for now. So this is all flexible and this is all low traffic intensity. Now I have my PCI, so I need to sort it based on PCI. And I'm gonna sort it from high to low because this will be good value, right? It's brand new. As I go down, my lowest value, 49, well, it's not that bad actually. And now I also need to establish what is good and what is not good. So let's look at the range of PCI 2009. It goes from 45 to 100. But now I have a problem. I have to say 2009, 2010, good, fair, poor, very poor. Good, I know, goes from somewhere to 100, right? So maybe 70. And fair maybe goes up to 70 or 69, 99, 99. From what, 50 maybe? And the next one is up to you guys. You have to tell me, maybe 30. I don't have very poor. That's what I'm trying to get to. Because my smallest is 45, I believe.
Yes, it's 45.
See, 49 in this case, but 45 in the general. So I am only gonna have this. So what is my good? Average up to 70. But we can change it, right? We can adjust a little bit. Do you guys want me to adjust it? If so, just tell me the value before I start the calculations.
Yes.
Okay, this is good, or you want me to adjust it?
Yeah, adjusted.
Tell me the value.
Okay. 65.
It's too low for good.
80.
Hmm?
Make it 80.
75.
85?
75.
Okay. You want me to change those?
55 maybe.
So I have a span of 25 here. I have a span of 20 here. I have a span of
25.
25 again. Shall we keep it like that?
Can we make the 30 20?
And then what do we do out of the very poor? 0 to 20?
Yes.
We have up to 49 only.
We have up to 49. So we only have good and fair. And that means we only end up with how many points on the graph?
2.
No.
No, we do have poor. I mean, it's from 55 to 49, right? So we will have like 3 different ranges, right?
How many points on the graph?
6 points.
Yes.
Yeah.
I'm gonna keep it like that. I'm gonna start the average now. Are we including the 75 or not? Yes, we are, right?
Yes,
It's better to
Yes.
include 100 to 85 for good,
85 or 75?
5 to 60. 85. 75 is a large portion of the data.
Okay, so you want to increase this.
Yeah, maybe 80.
Maybe 80, so this span is 20. This is 20, and let's make this span 20. Up to what value then for 80? 296. And then from 297, I don't know where. Let's see. What is the 55 to 80? 55 to 80. 279 here. So it's 297 and then 55.
Excuse me, it must should be 59 if you consider 24.
Just a second, please. Okay, you're saying? It will be 60, right?
Yeah, 60.
Or 65 even.
No, because I want 20 separation.
Yes, but the portion of the data will,
No,
in
guys,
this
it's
case,
not about the
will
portion.
not be.
It's not about the portion of the data. It's about what makes sense in terms of your ranges. Of course, you try to balance, but you have sufficient data points. How many do we have? 1,145 observations. If you only have 1 or 2 or 3 or 5, but that's not going to be the case, you still have sufficient. You cannot make a range of PCI that doesn't make sense, right? Like I cannot go with my good all the way down to 60. My fair in 80 is a bit too high for my taste. My poor up to 60, 59.99 is a bit too high for my taste. But
Excuse
okay,
me.
we can try. Yes.
I think that the distribution of our data is not important here in this case, and we have just pay attention to the definition of good, fair, and poor condition of the pavement.
Mm-hmm.
So
correct.
the distribution is not important here.
Yeah, correct.
Okay, it depends on the condition of the pavement. So we can use the same as these data, these spans that you got.
Yeah, that's fine. But do you see also the problem of the PCI once more? We cannot agree what is good, what is fair, and what is poor. We were able to agree on RI, and I'm sure if I put cracking or rutting, it will be much easier for us to agree. Do you see that?
Yes, of course. Yes, of course. If we had IRI, we could make a decision better.
Yeah, and if we have cracking or rutting, or deflection basing area or structural number is even better than that.
Of
Okay,
course.
so let us just continue with these ones, okay?
And this goes to that question in the midterm also, right? The PCI is not the best indicator.
No, it is not.
Yeah.
So 60 to 80, 297 to 497. Okay, down to 60, right? So it's 10, 15. 10, 15 is 60. And my next range will be 10, 15 down. 10, 16 actually. Roll it to the last one. Let's see. 10, 16. Is 60 to 1145. It's gonna give me the same result because it's counting how many. Okay, so now this one is the same, but it's for 2010. So in this case, it's next door, so I can just drag it. And now I have my values. So I can go with these values now into my calculator. Now, 100 is 0, that's fine. We arbitrarily selected this and we need to respect it now. So we choose this. So this is 80. This one is 60. This one is 40. This one is 20. Now, the separation is 1 year, right? Because it's 2009 to 2010, correct? Now, the values I don't know are these. This one doesn't matter because I don't have information. Oh, this is copied manually. Yeah, so don't pay attention to this. This information is not there. It should have been linked to that. So this is not linked. So hold on a second. It's not linked. So this has to be this one. 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 Oops. And this has to be this one. Okay, so now I need 1 year. Oh my, I'm in trouble. You see how they're all related?
You change one, the other one changes, right?
Yes, because this value, one of these values is going below the point. You see the 58 is below the 60. And the 77 is below the 80. And the in this case, the 47 is not. But this is the reason why you have in the equation, you have all these other ones.
Yeah.
Because of those dependencies. Okay, that's good enough for this case, believe me. What did I did? 5.7. Okay.
You think changing the initial range would have helped us? I mean, say 100 to 70, and then 70 to 55, 55 to whatever.
It will change the average. This average will change.
Yeah.
And you end up in the same position.
Okay. Okay.
But let's see what is happening. Let's see what is happening. You see how fast is this deteriorating?
Yeah. So in 4 or 5 years, it's basically going from 100 to 40.
Yeah. So let me put here a couple no, I don't have values. What is the equation? Linear. Okay. So that's my equation. It is PCI is Y, right? And X is my apparent age. So the PCI 40 is almost at 5, I would say, right? What happens if I put a 5? Let's put here PCI equals, and then X equals, X is my apparent age. So let's put 5 minus 11.875 times that plus 102.55. Actually, if you notice, the equation is incorrect. Should be plus 100, right? I should force the intercept to be 100 in this equation, but just for now, let's keep it. It's 43, at 6 is 31, at 7 is 19, at 8 is 7. How much is the life, not service life, life only of a pavement in Montreal? From 100 to 0 in PCI, as per the measurements of whatever is behind PCI, which we don't know, it's a black box for us. But how long is the life, not service life? Service life is the moment at which you can do a reconstruction. The life is the moment from brand new to fully destroyed. 9 years, 8.6 years. You see how short is the life of a pavement in terms of PCI for this type of road, which is the one that we were doing, this, which was flexible low?
Yes.
Flexible law. We can get the rigid if you want.
If you see, just based on the line, I mean, in 5 years it's going from 100 to 40, which
Yes,
means in like in next 4 years it's going to almost to 0. So basically, it's very fast, like exponential kind of deterioration. I mean, it's linear, but the rate of
is very fast. It reveals two problems. One problem is the PCI. Using PCI, we don't know what if there's something that is being used. Maybe the roughness has a high contribution factor for this PCI. Maybe the structural capacity is still good, but the roughness is not because of the freeze-thaw cycles. We don't know. The second thing that is revealing is that this is deteriorating fast. As you can notice, the rate of deterioration in PCI is fast. Seems reasonable for Montreal. If you know Montreal roads, they deteriorate fast, but maybe not that fast. So the use of the PCI is not advisable. Problem is sometimes the World Bank hires you as contractor, consultant, and all they give you is PCI. And you need to make some sense out of this and also use this type of things to show them that they need to collect other information.
But we have that Patterson model, which is basically which uses IRI in the absence of any data. Isn't
yes,
there?
But you have data here.
Isn't there an equation? Yeah, we have data, but isn't there like a sort of like a corresponding equation like Patterson model that we can use for PCI in the absence of any data? Okay, here we have like a 2-year data, but let's say
no, because what the World Bank has proposed is the use of roughness, International Roughness Index, not PCI.
Not PCI, okay.
And there's no corresponding equation that gives you PCI.
I see, okay.
But sometimes you have a bridge condition index or culvert condition index or any indicator that goes from high good to low bad. Deflection basin area, for instance, goes from good 36 to very bad 11. It will follow this calculator that the PCI is using because the trend is up down.
Okay.
RI is down to high.
Yeah.
All right, guys, I'm going to stop here because we need to talk about the midterm. So I'm going to stop recording.